Whoa, what are these? Whoa, what's going on? Whose birthday is it? Mr. Newbold. Whoa, it's my wife's coming up soon. So I got her some All Creatures Great and Small movies there because she's British and she really loves this. She loves this show. Highly recommended. PBS. And so I ordered those off Amazon. And then I got her a little necklace with the stone rolling away. Okay, here we go. Let's see. So helping you guys on statistics, 8.2 margin of error. So this assignment sounds scary, but it's actually not too bad. Pretty easy to calculate. The definitions can be a little tricky, so I'm going to help you with that. So basically, matching definitions there. So margin of error accounts for variation in results if the study or simulation were conducted multiple times, right? You got to do it multiple times. If you're going to do it multiple times, then you'll account for a margin of error. Confidence interval is a range of possible values to the left and to the right. Range of possible values for a population parameter. So the confidence interval is trying to capture the actual average of the actual population, whatever that is. 9 billion people in the world now, is it? So that's confidence interval, trying to capture the actual population average. Now confidence level is how likely it is that an actual population parameter falls within that confidence interval, right? So if you're like 95% confident that the actual population will be within that interval, that confidence interval, yeah, so usually we like to do about a 95% confidence interval level with an alpha of 0.05, 5%. What's the sample proportion? So the sample proportion is the probability of an event occurring based off of a sample data. So it's just like a sample, right? Sample mean, sample average, but it's a proportion. So like 15 out of, like for example, here's a good example that also has to do with 68, 95, 99.7. So 17 of my 25 students had heights ranging from 5'4" to 6 feet tall, right? So like 54 inches to 72 inches. And so that's 68% of my population. That's within one standard deviation. Whoa. Because our average was 68 and our standard deviation was 4.1, 4. And so anyway, so proportion is like more of just like a fraction, a proportion. Okay, the mean, of course, you already know, is the average of a set of data. And the standard deviation is a measure of how much variation is present in a set of data. So standard deviation is basically, I like to say it this way. So standard deviation is you take all your data, find the average, and then you calculate it by doing the average distance. So you do all the distances to all your data, and then you find the average of those distances. Some of the distances will be negative, some will be positive. So because the negative distances, we have to square them all, and then at the end, square root it. So if you see that standard deviation formula, that's why. Cool. So then if we use the 95% confidence interval, which means a z-score of 1.96, please use the given sample proportion p, standard deviation, sample size n, and the mean given to find the margin of error, right? So here's our confidence interval calculator, that's our formula, as well as our margin of error formula. And so they want us to, for example, for this number 1 problem, so they want us to find of the margin of error as well as the confidence interval. And so how we do that is, here we go. So we use the formula. So we have a z-score of 1.96. We have a standard deviation of 0.04. And we have a sample size of 400. So we go 1.96 times the standard deviation on the top, so that's 0.04, divided by the square root of the sample size, which is 400. Nice. And so we'll go and use our calculator to calculate that. And so we go 1.96 times 0.04 divided by the square root of 400, close parenthesis. So that gives us 0.00392. So 0.00392 is what we're looking at there, which might be close to the answer that we have. Maybe I need to fix it. So 0.00392. I guess that does round up to 0.004. So we'll take that. We'll take that. Okay, now to find a confidence interval, you're going to take the average they give you, which our average here was 1.75. Now, even though it does say the sample average, it does say, okay, it does say sample size n and mean. Okay, so we'll use the 1.75 and the 0.04. Okay, so here's how you do the confidence interval, right? So then the confidence interval, here we go. There's our formula for confidence interval. Okay. Sorry. Okay, here we go. Okay, so again, we have our average, and our average was, now we get to use the average. We didn't use it in the last formula. So 1.75 is the average that they give us. That's the mu. And then we're going to do plus or minus. So plus the z-score, which is 1.96, times the standard deviation again, 0.04. Which, okay, so we already calculated this, didn't we? We already calculated this, okay? We already calculated this. So all we're going to do is take our answer we got, which is 0.004, and we're going to add it with 1.75 and minus it from 1.75. So we take 1.75 and we add 0.004, and we take the average 1.75 and we minus 0.004. So that gives us 1.754. That gives us 1.746 to 1.754. And there it is, 1.746 to 1.754. Cool. So you're going to do that same thing with this one. Margin of error. Oh, they give you the margin of error. What's the sample size? Whoa, that's interesting. That's interesting. So in this one, you're going to solve for they give you the margin of error. Wow, that's interesting. So they give you the margin of error, and they want you to solve for the sample size. So that's 0.10. They give you the margin of error, and they give you the standard deviation, which is 1.5, right? And then they want to know the sample size. That's interesting. That's interesting. Okay, so then what we have to do basically is we have to switcheroo. So we're going to take the 1.5, so we're going to switcheroo, right? We're going to multiply radical x over to this side and divide the 0.10 down to this side. I'm pretty sure we're using a z-score of 1.96 still. So if we don't get the right answer, it's because of the 1.96 that I forgot, but we'll see. So then we went ahead and divided the margin of error. So we divided the 0.10 down to this side. And so now in our calculator, we're going to go the standard deviation 1.5 divided by the margin of error 0.10. And then we're going to go ahead and square that sucker. So we get 225. So 225 is our sample size. Now there's a chance that they took the 15 and they times it by the 1.96 standard deviation first, maybe, and then squared it. So it could be 864, but I don't know. Let's see. Here we go. So the sample size, what the 900 and 900? That's ridiculous. They just doubled the margin of error, doubled the standard deviation, so the sample size is the same. Yeah, so they must have taken it and times it by the standards. You know the z-score, the 1.96, which went right here. Yeah, so they must have done that and rounded up to 900. Sorry about that. That's kind of a lame problem. So definitely would probably want to change that, and to make sure to list on there, right? Make sure to list the z-score being used. So what sounds like I need in order to produce a desired margin of error using a 95% confidence interval and a 1.96 z-score. Don't forget the formula. So we go up here, it tells us the formula, and we've been using a z-score of 1.96. So I'm pretty sure we'll just use this and round up to 900, which is lame, because I'd really like it to be the 864.36, maybe round that up to 865 would be better. There we go. Okay, so we're going to update that question, try to make that sound a little better. It's a good thing we did that. And you're going to do the same with these ones as well. And so use the population, but we will make another video, but hopefully that helps you so far. So thanks for watching, appreciate you. Thanks for learning with me. It won't be as tough on the test, I promise. Thanks for watching. Bye for now.